Yes, hello, my dear students. Good evening, all of you. Then come to the live session. My name is Lakshmarana. This is Ellen Brand of Chemistry. Today we are going to discuss about the factors affecting the rate of reaction. So in our afternoon session, we are discussing some of the topics. So now continuation of that particular topic. Come to the live session. Yes, come to the live session, my dear students. Good evening, all of you. Good evening. Come to the live session. My name is Lakshmarana. This is Ellen Brand of Chemistry. Today we are going to discuss about the factors affecting the rate of reaction. Factors affecting the rate of reaction that we have to discuss. So in that fourth factor, actually the previous three factors we are discussing in the morning session. So now we are discussing that is fourth topic, fourth effect of concentration of reactants. So here the concentration of reactants, the effect of concentration of reactants can be explained by law of mass action. So effect of rate of reaction can be explained by law of mass action. Law of mass action. Law of active mass or law of mass action we call. So what is the law of mass action? Law of mass action is what? So what is the law of mass action? So it is at a given temperature, the concentration of reactants, the product of concentration of reactants is directly proportional to rate of reaction. So here what I told, at a given temperature, rate of reaction is directly proportional to product of concentration of reactants raised to the power of stoichiometric coefficients. Stoichiometric coefficients in balanced reaction. See, look, my dear students, observe it carefully. So what I told, the effect of rate of reaction can be explained by the law of mass action, right? So what is the law of mass action? At a given temperature, rate of reaction is directly proportional to the concentration, product of concentration of reactants. So product nothing but the multiplication. So product of concentration of reactants raised to the power of stoichiometric coefficients. So in the balanced equation, for example, one of the equation I'm taking, that is just general equation I'm taking, 2a plus 3b gives rise to c, like this will be there. See, for this rate of reaction is directly proportional to concentration of A raised to the power of stoichiometric coefficient, then concentration of B raised to the power of stoichiometric coefficient of this. Right, so product of reactants raised to the power of stoichiometric coefficients. The rate of reaction is directly proportional to, then what I told, concentration of products, the concentration of reactants, product of concentration of reactants raised to the power of stoichiometric coefficients. So here the R equals to K into, so then A power 2, then B power 3, you can write like this. So that indicates that rate of reaction is directly proportional to the concentration of reactants. See, we can say that for general reaction, one more, then A gives rise to B, or we can say R, reactant can be converted into product. So here in the rate of reaction generally ela express chestam. So expression of rate of reaction equals to minus dr concentration divided by dt, right, with respect to the reactants. So that is equals to what I told, the concentration of n to the power. So n, it is a stoichiometric coefficient. Here 1 is there, 2 is there, or so whatever the value is there. But here one of the thing that you have to tell, so this number is not a stoichiometric coefficient. For zero order reactions, that is 0. For first order reactions, in value 1. For other order reactions, so whatever the value will be there. So for zero order reactions, for zero order reactions, if you take, then that is R equals to, then in case K into concentration of A to the power 0. So that we can say R equals to K. The rate of reaction is constant for the zero order reactions. So in case if you take for other order reactions, for other order reactions, for the other order reactions, so R equals to K into, so R to the power n. So n is order of reaction. So n, it may be 1 or 2 or something like this will be present. Clear, my dear students? So that is what we call, so rate of reaction is depends on that. See, it depends on concentration of the reactant. See how these are reacted, concentration. In case if you take for the gaseous reactions, the same thing. In case if you take for gaseous reactions, for gaseous reactions, rate of reaction R equals to K into P power n. P nothing but a pressure. For gaseous reactions, we are not using concentration, we are using pressure. So even here also n equals to order of reaction getting. See, all these things are explaining that rate of reaction is directly proportional to the concentration of reactants or partial pressure of reactants in case if it is a gaseous reaction. See, I told that concentration of reactants are increases, rate of reaction increases. Then why concentration increases, rate of reaction increases? See, actually, once concentration is increases means the number of particles per unit volume increases. Once the number of particles per unit volume increases, then more number of collisions are happens. That means more effective collisions takes place. Once more effective collisions takes place, rate of reactions increases. So that is what I told. When concentration of reactants in reaction mixture increases, increases, number of molecules per unit volume increases. Per unit volume increases. That you have to observe. So number of molecules increases. What is rate? Concentration increases. Then number of molecules per unit volume increases. So once number of molecules per unit volume increases, what increases? So number of effective collisions increases. Number of effective collisions, number of effective collisions increases. Hence rate of reaction increases. That you have to remember, my dear students. Clear, all of you? For example, one of the reaction we are taking zinc, when it is treated with HCl, that is dilute HCl, take it as dilute HCl. Then, so same reaction, zinc, when it is reaction with HCl, concentrated HCl. So the both reactions if you take, which is slow reaction, which is fast reaction, man? So wherever the concentration is there more, then that reaction is taking place faster. Wherever the concentration is less, that reaction is taking place slow, right? So what happens in this case? Actually, what happens in this case? So ZnCl2 plus, then hydrogen gas will be liberated. ZnCl2 plus, hydrogen gas will be liberated. Of course, formation of products are same. But in this case, it is a slow reaction. In this case, it is a fast reaction because it is a dilute, it is concentrated. Where the concentration of reactant molecules are increases, there fast reaction takes place. Understand, all of you, my dear students? So this is the effect of concentration of reactants. So simply we can say that the rate of reaction, it is equals to K into then concentration of reactants. So rate of reaction increases when the concentration increases. That will be explained by law of mass action. See here, the law of mass action, nothing but what you have to take here. Square bracket, we are taking nothing but number of moles divided by volume. So number of moles divided by volume, nothing but it is a molarity. So remember, my dear students, the molarity equals to number of moles divided by volume in the liters only. Clear or not? So active mass anna, then square bracket to representation, number of moles divided by volume representation, that is molarity. So actually this molarity for the solids or pure liquids, in case if you take pure liquids, that active mass, that is molarity, active mass, it is equals to 1 unity, we call 1 we can take. Clear, my dear students? Understand, all of you? Right? So effect of concentration of reactants is this. Then effect of temperature have to discuss. The effect of temperature have to discuss. Effect of temperature on rate of reaction. Effect of temperature on rate of reaction. So how the effect of temperature will be present? See, remember, rate of reaction increases when temperature increases. Listen, my dear students. Rate of reaction increases when temperature increases. When temperature increases. Rate of reaction increases when temperature increases. So why rate of reaction increases when the temperature increases? See, again here what happens, once the temperature increases, more number of molecules get energy that is equals to activation energy or more than that. See, when temperature increases, then what happens? Molecules get, more number of molecules get, remember? More number of molecules get energy equals to or more than activation energy. So what happening there? Observe it carefully. Temperature increases, more number of molecules in the reaction mixture. For example, just assume it. So we are taking 100 of molecules. So in this, before adding temperature, only 50 molecules having the activation energy. That means the rate of reaction is slow. Once temperature increases, then some more molecules can get activation energy. That means 30 more molecules when it is added to 50, then 80 molecules get activation energy. So that what is happening there? Rate of reaction also increases. So that is what. So once the activation energy increases, then rate of reaction increases. So once more number of activated molecules are increases, hence rate of reaction increases. Rate of reaction increases.